Alright, today we're going to talk about rational versus irrational numbers. So, just the definitions. Rational numbers are any numbers that can be written as a fraction, and irrational numbers are any decimals that never end or repeat. And we'll get into some examples here in just a second. Alright, so now we're going to classify and put some examples to these for the rational and irrational numbers. So, like I said, rational numbers are anything that can be written as a fraction. So you can start with just fractions. So, 1/3, 1/2, so a fraction. And if you know these fractions that I wrote, 1/2 as a decimal equals 5/10. So decimals are also rational numbers because they're equivalent. If you think of whole numbers, the whole number 5, that can be written as a fraction. 5/1 equals 5. So whole numbers are rational numbers. And then 1/3 up there, that won't let me move it. So I'll just continue down here. 1/3 equals 3/10 repeating, and it can be written as a fraction of 1/3, so it's automatically rational. So any decimal that can be written as a fraction, any whole number that can be written as a fraction, and they can even be negative. So we could have -8, which you could put -8/1, which equals -8. So that too is a rational number. So irrational, like I said, is any number that never ends and never repeats. And there's two main forms that you're going to encounter. The first one is pi. You've probably seen that before when you're working with circles. And we estimate pi to be 3 1400ths. But in truth, pi goes on forever, never ends, never repeats. The other case you're going to get is with square roots. Let's say we have the square root of 60. And when you do the square root of 60, it's not a perfect square root. So you get a decimal that is about 7 7/4 9 6 6 6 6 9. And you can see that there's no real pattern there, and it just keeps going and going. It's never going to end. You're basically doing the problem forever. So that's why it's considered irrational, is because it never ends. So in theory, you'd be doing the problem forever. One more note on the rational numbers. There are square roots that are rational. So if we did the square root of 25, well, 5 times 5 is 25, so the square root of 25 is 5. And we already said 5 is a rational number. So any square root that's perfect is a rational number. All other square roots are going to be irrational. There's another case that you might run into. So say we have the number 5.12, 112, 1112. You'll notice I have a pattern going here. So I'm adding an extra 1 each time. That is a pattern, but it's not repeating. Repeating would mean I have this 12 over and over again. It's not. It's 12, then 112, then 1012, 1112. So that is not repeating. So that would fall into the irrational number column. So that's the difference between rational and irrational numbers.